Okay, so here's my idea for this lesson. I'd like you to play this game. We typically play this in class and discuss it as we're playing, but I think we can do it this way. If you go to colbymath.com, click on the Math Arcade, scroll down until you see Save the Zogs. Don't click on the picture. I don't have that linked right. Just click on the text here and that will take you to the game. I believe I also linked to the game in the email I sent you this morning, so you can probably get there directly from that link. Now, if you don't see this screen, or that you're getting some kind of screen telling you that you can't access it, look to make sure Flash is allowed on this page, or try a different browser, or see if there's someone around there that can help you figure that out. But if all else fails, you can play it by watching or you can sort of play it by watching the video instead. I mean, you can watch me play it. That's basically what I'm going to do on the video. And I'm not going to make you watch the whole video, but please don't go until I tell you that you can go off on your own, because I want to just say, I want to explain how you can use the video before you stop using the video. And I wouldn't stop using it, I would just minimize it and then go play the game. But let's read this story. 4 frightened Zogs have left the safety of their planet and are floating around in space. The Duplicators, a band of space travelers with the ability to imitate others, have infiltrated the floating Zogs. This might remind you of the Wumps and the imposters. But it's a different, dealing with a totally different type of math, but same kind of idea for the story. Fortunately, the Zogs are very clever. They can position themselves along a straight line path like these 4 Zogs. The Duplicators cannot. If the rescue team can determine the equation of the line, then the Zogs will be saved and the Duplicators will be left behind. Your mission is to rescue the Zogs by learning as much about linear equations and the lines they create as possible, and what happens when the slope is 0, what effect does the y-intercept have on the position of the line. The more you know, the more Zogs you can save. So I want to show you some controls before you go off on your own. You have tracking controls. This X position, if I drag this, I didn't read it right, Y position. You see that little green line that moves up or down as I change the Y position? That's not the line that you want necessarily, but you can move it. You can move this line around to try to visualize the line you want. The X position moves this little dot. The slope changes the slope of the green line to different slopes, and once you change the slope, you can move the line around to where you want it to be. Okay, so let me put it back like it was. It was right there. What is the line? So where are the Zogs? There are 2 Zogs in a line here, but any 2 Zogs would make a line, right? The Zogs are right here. So I want to move my line up to where they are. And my y-intercept is 10, positive 10. And the slope is 0. So if I'm thinking about mx plus b, y equals mx plus b, that would be y equals 0x plus 10, or just y equals 10. So if I think I have the right equation, then I hit rescue, and it will verify it. If we make a mistake, can't make a mistake except on the next slide. I'll make a mistake on purpose and show you what a mistake looks like. I see my 4 Zogs right here, so I'm going to move this down. That looks like y equals -4. It looks like I've got another horizontal line with a slope of 0, but I'm going to pretend I misread it or made a mistake. If I say x equals -4,
Try again.
it'll show me where that line would have been, and let me try again. But we know it should be y equals -4. See, I'm on level 1. I've done 2 of 3 screens on level 1. The next screen will move us to level 2. Alright, I see my Zogs right here, but they're not horizontal now, they're vertical. So this is when first I want to move my line off the axis so you can see it, and then I want to change the slope to vertical, and then I want to move the x over to there. See, this is a linear equation, it's just not a function. I mean, anything that graphs as a straight line is linear equation, but this would definitely fail our vertical line test. That vertical line goes through all 4 Zogs. So here, rather than y equaling something, x equals something. X is constantly 8. So this is the equation of x equals 8. Move on to level 2. Now the levels get harder as you go, and the types of things you're able to do and what it's asking you to do changes. So that's what the video is for. If you can figure it out as you go, that's probably actually the best, like playing around with it and figuring it out as you go. But if you hit a sticking point, if you're like, wait, what's it asking me to do? I don't get it. Just forward until look on the video for the level that you're on. Forward the video to the level you're on, and then listen to me talking about it, and then that will help you get past that point where you're stuck and move on to finish the game. It's weird for me to. There's no assignment tonight other than to play this game, so I don't want to express an expectation about how long you should be playing, because I don't actually know. I'm going to play through every level possible right now, and I don't know how long it's going to take, but the length of the video will give you an idea about how long that you should spend on the game. If it gets to be too long, if I'm sitting here for too long, then I'll give you some guidance, probably in my email. But otherwise, just try to play through all the levels. Use the video to back you up if you get stuck or not sure what to do. Okay, so here on level 2, I'm trying to figure out the equation of the line rather than having a multiple choice. I'm moving my line down to here because I see my 4 Zogs down there. My horizontal line has a slope of 0, but the y-intercept is -10. So this looks to me like y equals -10. Y equals, because it's a horizontal line, and then I choose the value here, -10, and then rescue. I have another horizontal line. Those 4 Zogs are right there. I'm not going to move the line this time. I just know that it's y equals +8. Y equals +8. You don't have to move the line to the Zogs if you can visualize it. Really, the line's just there. I'll show you. I'll move it to a place where the Zogs are not. It's going based on what I'm saying the equation is. So it counts that. That light green line is just to help you visualize your line. Next. Now I have a vertical line. And so this is not y equals, this is x equals. X is constantly 7. X equals 7. I'm going to move that line to help you see that. X equals 7. Now in the work we've done up till now, we haven't done lines, we haven't done vertical lines except to say that they're not functions. You're not really going to be dealing with vertical lines, but they're part of the game here. Now they give us the equation and we need to show them the line. So if x equals 3, I know that's a vertical line, so let's change my slope to a vertical line. And then let's change the x position to 1, 2, 3. And you point on that line, the x value is 3. The coordinate of the x coordinate is 3. 3, 0, 3, 1, 3, 2, 3, -1. That looks right. And then it shows that it went through the 4 Zogs, so we have the right equation. Y equals 9. I'm just going to, the default is a horizontal line, so I'm just going to move it up to +9. Because I know my y-intercept is +9, and I know my slope is 0. X equals 2. Move my x position to 2. Change the slope to vertical. And I should have my line. Level 4. Now level 4, now no more vertical or horizontal lines. Now we have lines with slopes. And I'll be honest, I'm a little, here's the first line I saw. That's the first line I saw. The duplicators tricked me because 2 of 3 of these points are duplicators and only 1 is a Zog. The Zog is at the origin. The other Zogs are actually over here. So remember, it has to be 4 Zogs in a row. Now that I know where the line is and where the Zogs are, I need to write an equation for that line. I wonder if I almost said I wish I could write on my screen, but you know what? I think maybe I can. I've got this app that I never use. Let me try this. No, that's not it. Let me try this. Oh, what do you know? Okay. Y equals mx plus b. And I know my y-intercept, b is 0. I can see that because that's where my line's intersecting the y-axis. And now I just need to know what m is. M equals, well, delta y over delta x, right? If I use these two Zogs, let's just start at this Zog. I'm going from this Zog to this Zog. My change in y is 1, 2, 3, 4 down, so negative 4. And then I'm here, and I need to go 1 to the right over positive 1. So m is negative 4. So y equals negative 4x plus 0. But if it's plus 0, I don't even need that term. Just y equals negative 4x. And so I think this is my line right here. I could have probably done it by, I could have limited it to these two just by knowing it was a negative slope, a downhill slope, but I still would have had to calculate the actual slope. Alright, now, where are my 4 Zogs? This is where this thing comes in handy because, to be honest, it's not easy to see. I think they're right there. Yeah. Alright, so I've got another y-intercept of 0. Oh, I keep picking the wrong app. I've got another y-intercept of 0. So b is 0. My slope, let's pick two that are close together, like these two up here. My delta y over delta x. If I go from this Zog to this Zog, my delta y is, I'm going down 2, so negative 2. My delta x is right 2, so positive 2. 2 divided by 2 is 1, and a negative divided by positive is negative, so negative 1. So the slope m is negative 1. So when I write y equals mx plus b, y equals m is negative 1, so negative 1x plus 0 is just y equals negative x. Because this constant term is 0, it disappears, and 1x is x, so negative 1x is negative x. So y equals negative x would be the right line. I see my line. I see my Zogs are right here. Let's do process of elimination on this one. Let's do it a little differently. Is this uphill or downhill? If you were walking from left to right, if you were walking from left to right, we're going uphill, right? So it's not going to be a negative slope, it's going to be a positive slope. It's one of these last two. And then let's do let's pick this Zog and this Zog. Delta y over delta x. If I'm going up 1, 2, 3, 4, so positive 4 for change in y, and then right 1, 2, so positive 2 for change in x. So the slope equals 2, so it must be this one right here, y equals 2x. Level 5. This game is fun, even if you didn't have to do math. What could be more fun than saving the Zogs? Oh, there's the line. There it is. Alright. What's it asking me on this one? Oh, what's the equation? So it's asking me to write the equation, but it's recognizing, or it's hoping that we recognize, that since the line intersects at the origin, there is no constant term, there's only the variable term. So if we just know the slope, we can change the slope here on this slider to negative 5x, 2x, 3x, whatever we think it is. It's uphill, so it must be positive. You know, you don't even need to use two Zogs necessarily. If you know it goes through the origin, go from the origin to the Zog. Delta y is up 1, delta x is right 1. Positive 1 over positive 1 is 1. So y equals 1x, which is the same as y equals x. That's the multiplicative identity. 1x is x. By the way, I know that the problems they're giving you are different than the problems they're giving me. I'm just showing you examples so you could use the examples. The idea is to solve your problems. Okay, where are my Zogs? There they are. This is a very steep uphill slope. So I expect something high, like 4x, 5x, I don't know. But going from this Zog to this Zog, delta y would be up 1, 2, 3, 4, so positive 4. And then right 1, positive 4 over positive 1 is 4. I just landed on it accidentally. Y equals 4x. There they are. Alright. I'm going to use Zogs that are close together. Again, it's uphill, so positive. I'm going from this Zog to this Zog. My delta y would be up 1, 2, 3, 4, positive 4, over right 2, so positive 4 over positive 2 is 2. 2x, y equals 2x. Level 6 of 28 levels. Just kidding, I don't know how many levels are, to be honest with you. You have the equation, now show us the line. Ooh, y equals negative x. Alright, when I see y equals negative x, I want to think about y equals mx plus b. Negative x is your mx part, but what's plus what? It's plus 0. So b equals 0. That means my line intersects at the origin. And then mx, negative x and mx. What is m if my variable term is negative x? What is m? What if my variable term was x? What would m be? X equals 1x. So in this case, m would be 1. Negative x is the same as negative 1x. So m is negative 1. So if my slope's negative 1, I wonder if it tells me. Oh, I can't do that. Okay, delta y over delta x. Negative 1 over positive 1 would be negative 1. So I'm going to have to close this out in order to actually use the other functions here, but I want a slope of negative 1. First of all, I don't want anything uphill. It's negative 1. I want a downhill slope. And I want to go, we said, down 1, right 1. Here's what you can do. You can pick a point that you know, like the origin. We said plus 0. So we know it crosses at the origin. And then you can go down 1, right 1. And then you can make your line intersect that point. That's what we should do. But I can't show you both things at once. But remember, we put a point right there. And so down 1, right 1 would be a slope of negative 1. And so that looks like we've got the right line now. Y equals 4x. Alright. Which is the same as 4x plus 0. So I know it crosses at the origin. So all I need to do is mess around with my slope until I get a slope of positive 4. So just using the arrow here, if m is positive 4, delta y over delta x would be 4 over 1. So you go up 1, 2, 3, 4, and right 1. So I'm going to want to change my slope until I intersect it at this point right here, 1, 4. Like that. Up 4, right 1. There it is. Positive 2x, so up 2, right 1. Up 2, right 1. There's my line. Level 7. Oh, now it's getting harder. Let's move this line. I see they're here, but I can't just change the slope. I also have to change the y-intercept. Ah, the y-intercept. So we see this zog crossing the y-axis right here. So I move my y position up to there. Positive 5 is the y-intercept. So we're thinking about y equals mx plus b, and I see that b is 5, positive 5. And then I think about my delta y over delta x. If I'm starting at this zog and going to this zog, I'm going up 1, 2, 3, 4. So delta y is positive 4. And then I go up 1, 2, 3, 4, and then I go right 1, so that's positive 1 for delta x. 4 over 1 is 4, so the slope is 4. So I substitute that into my linear equation. I get y equals m is 4, so 4x. Y is positive 5, so plus 5. Y equals 4x plus 5. That looks like this third one right here. So when I close this, it's going to clear off all this, but 4x plus 5. Alright, good. I see them right here, so I'm just trying to make a slope that I think matches. I don't have to be right. I'm going to be wrong on purpose. I'm going to be slightly wrong on purpose. And then I move my y to the y-intercept, which is this zog down here at negative 7. And then if I see I didn't get my slope quite right, I could adjust it. Alright, now I've got my line going through my zogs. So I'm going to do the same thing. I'm going to write y equals mx plus b. Because if I can find m and I can find b, I can rewrite it and get my actual equation. The line intersects at negative 7 on the y-axis, so b is negative 7. The slope is always change in y over change in x. Let's go from this zog at our y-intercept to this next zog up here. The change in y from this lower one to this upper one would be up 1, 2, 3, 4. So that's a vertical change of positive 4. And then from there I need to move 1 to the right, so that's a horizontal change of positive 1. So again we have a slope of 4, positive 4. When you substitute into this equation, m is positive 4, so 4x plus b is negative 7. Now you don't see 4x plus negative 7 here, but you do see 4x minus 7. Remember, 4x minus 7 is the same as 4x plus negative 7. That's the definition of subtraction. Subtracting is the same as adding the opposite. And so even though this doesn't look exactly like this last one, they're equivalent. And so that's our answer, the last one right there, 4x minus 7. You see my y-intercept is down here at negative 2. So I'm going to move my line down there. Then I'm going to adjust the slope until I'm going through 4 zogs. There they are. Alright, and then I'm going to write the formula. Y equals mx plus b. My beginning point, my slope, the point where the line intersects the y-axis is 2 below the x-axis, so negative 2. Slope is your change in y over your change in x. I'm just going to go from this one to this one. So I'm going up 1, 2, 3, 4, 5. So that's a change in y of positive 5. So move up 1, 2, 3, 4, 5. And then I have to go left 1. Left 1 is negative 1x. Positive divided by negative is negative, and 5 divided by 1 is 5. So m is negative 5. And that makes sense because if I was walking on this line from left to right, I would be going downhill. That's a negative slope. So when I substitute these values, m is negative 5, so negative 5x, b is negative 2 plus negative 2, but like we talked about before, that's the same as minus 2, negative 5x minus 2, which is the second one right here. I have to clear this off to click on it. Negative slope, negative y-intercept, everything looks good. Level 8. My zogs are way up here. I think I got the line. How is this one different? This one's not really different, except, I mean, it's asking for the y-intercept on a slider. The y-intercept is positive 8. And then when I give it a slope, what does it do? Oh, see what, that's pretty cool. Okay, if all I had was y equals 8, that would be a horizontal line. But clearly we don't have a horizontal line. We have an uphill slope, so some kind of positive slope. So I'm going to move my slope positive. And as I increase it, it goes 1x, 2x, 3x, 4x, 5x. So we just need to figure out what the actual slope is. If we look at these two zogs, the change in y would be up 2, change in x would be right 2. So 2 over 2 is 1. And so I'm going to change my slope to 1. And when I change my slope to 1 right there, it knows that 1x is x, so x plus 8. Here we have, oh, I can't do that. I'm doing the wrong thing. Right here. I don't see the, oh, I see them now. There they are. So my line is intersecting the y-axis at positive 2, so my y-intercept is positive 2. The slope, I'm just going to use these two, they're so close together. I can go from this one to this one by going up 1, right 1. Up 1, positive 1, right 1, positive 1. 1 over 1 is 1. So slope is 1. So y equals x plus 2. By the way, pick a value of x, like 6. 6 plus 2 is 8, right? So when x is 6, do you see that y equals 8? You see that points on the line? Oh, very steep line. Very steep, like that maybe. Intersecting the y-axis at negative 3. So my y-intercept this time is negative 3. My slope, I'm going to go from this one to this one. Delta y would be up 1, 2, 3. So positive 3 over positive 1. So the slope is 3. Level 9. Okay, they gave us an equation. We have to show them the line. I'm going to start with the beginning point. Actually, I'm going to start with this. This would be a mistake not to write this, as I've told you to do. Y equals mx plus b. And then I'm going to write my specific line. Negative 2x plus 3. That must mean b is 3. And that must mean m is negative 2. And m is change in y over change in x. So negative 2, I could represent as negative 2 over 1. I could also represent it as 2 over negative 1. But I guess the point is I want to move my... I can't move anything and still show you that. Oh, that's annoying. I don't think I have an option to... Oh, wait a minute. I just learned something. Okay. B is positive 3. M is negative 2. So basically from this point, we know the y-intercept is positive 3. From this point, I want to go down 2, right 1, according to my delta y over delta x. So down 2, right 1. Keep your eye on that point. I want to change my slope until my line goes through that point. There. Down 2, right 1. That should be our line. Y equals x plus 4. Y equals mx plus b. And then I write this equation, y equals x plus 4. Clearly b is positive 4. But what is x? What is m? mx is x. Well, x is 1x, so m must be 1. So delta y over delta x could be represented as 1 over 1. So I'm just going to move my line, my y-intercept first to 4, positive 4. And then I want to go up 1, right 1. I need to make my slope go through this point. Like that. Up 1, right 1. That matches the slope I wanted. I did it wrong. I had the wrong y-intercept. I wonder if any of you noticed that. There we go. Okay. Start the same way. Y equals mx plus b. And then write the equation. Y equals negative 2x plus 10. Alright, so b must be 10 plus b plus 10. B is 10. Mx, negative 2x. So m is negative 2. So my delta y over delta x could be represented as negative 2 over 1. So let's change the y-intercept first to positive 10, way at the top there, positive 10. And then I want to go from this point. The only point I know for sure is the y-intercept. I want to go down 2, right 1. So I want it to go through this point right here that I'm pointing at. That looks right. Down 2, right 1. Downhill slope, negative slope. Good. Mission accomplished. Excellent work. The Zogs have all been rescues. The duplicators are no match for your math skills. Thank you for a job well done. Click on the next button to play again. I don't know how long this video was. I do know, right about 30 minutes. That should be pretty good. Okay, so yeah, try to finish it. Hopefully you're using the video when you get stuck. And writing some things down, like I wrote them down to model that. If you want to make fewer mistakes, you want to write down the general form, slope-intercept form, and carefully consider the coefficient and the constant term, and represent slope as change in y over change in x. All right, class dismissed.